they had some good so
All right, anyways, we're not talking about Daredevil here from Marvel. This is 8.2 polar coordinates. There's a definition of polar coordinate. Polar coordinates consist of an ordered pair, r theta, where r is the distance from the point to the ocean, and theta is the angle measured in standard position. Of course, even when you use sonar or radar like you're talking about, somebody used to reconvert that into rectangular coordinates. I mean, that's what you grow up in. You grow up in rectangular coordinates, you grow up grabbing on the XY axis. So when you talk about sonar and radar, if you know something is 3 miles away at a bearing of 60 degrees, if you're actually going to put that and plot that on a map, you've got to have an ordered pair. But we will actually do a little bit of graphing polar coordinates, and then we'll get to the gist of it. The gist of it is to go back to the XY axis. That's really good of you realizing it was something like sonar and radar.
Thank you. Worked really hard on that.
But even that gets converted back to a grid, which is the XY axis. Nothing that I know of is actually graphed polarly. It can be. It just doesn't make much sense to it. It really doesn't.
Okay.
All right. So the big thing here is R is the distance of the point to the origin. That's what R is. So what's up first is to plot the point 3, 5 pi over 6. We're not drawing angles here, okay? Don't think you are. This is literally plotting a point. You need to figure out what 5 pi over 6 is in degrees, which is what? 150. Everybody know that? And then you have a radius of 3. This is your radius. So at 150 degrees, and we got all these circles here because each circle would represent one unit, wouldn't it? 3. That's all there is to it. Go to the angle, plot on the radius.
No.
Lines.
Yeah, the lines are.
I mean, I might be off just a
Should be
little
like
bit.
half a thing closer to the.
Each circle.
Oh, is each circle a 2?
Yes. So be between the first and second
Yes,
circle.
it would be. For some reason I was thinking each circle was a 1. Just make it really big. There we go.
Is that?
Not too bad, is it?
No.
What?
Now, the issue here is, what does that mean where anybody could read it? Like, what are the coordinates? Even this has to be, this is what you might see on a sonar map, but then somebody's got to give you the coordinates. So you still have to convert back to X1 axis stuff. All right, the next one, the radius is negative. What do you think that means? Go the opposite direction. You still follow the angle. You know, pi over 4 is going to be 45 degrees right here. Notice I didn't even put that on the grid. That's just for you all to realize what 45 degrees is. We're not going to move towards the angle. We're not going to move 2 units towards the angle. We're going to move 2 units away. That does get kids. So when it's negative, move away from the angle.
What if the pi over 4 is negative? That's not how that works.
Well, then you would rotate to negative pi over 4. And then you would look at the radius, whether it's positive or negative. If it's positive, you go towards the angle. If it's negative, you go away from the angle. Well, we can do that. I'll have no issues with it.
No.
I'm not. So maybe we do something like negative 4 or negative pi over 6. How many degrees is negative pi over 6? -30, that puts you on that angle right there, wouldn't it? And instead of moving 4 units towards, move 4 units back. That's all there is to it. Do we need to do a third one?
Did you say?
It's up to you. It is different. It is different.
So, -2 piles of 4 could be the same as, could it be the same as something involved in 210?
Which dot was
Or is that
that? That was the red dot? Yes, it could be the same as something involved.
Okay.
Because Cora's moved on to this question. Now, name 2 things equivalent. Cora said something.
Oh my gosh. I didn't
No,
see
what
that.
Cora said was right. Of course, she gave it in degrees, but she said not 210, 200 and what? 225. But the radius would be positive, because we would move towards the 225 degree angle, not away from it.
She said 210 could be put on 210.
Yeah.
Why is that dot even there?
That's the -2.
Because I'm stupid this morning. You should have corrected me. I've been having a lot of mistakes this morning. It'd be about right there, wouldn't it? Yeah. That's on me. Please tell me I'm recording, or did I forget to do that too? Did I record? Good, I did. Had to make sure the key was safe. All right, so that was an answer. Of course, you convert 225 into radian, which is, I don't know, 5/4. Sorry I made him teach today. I know you won't want me to, but I'm going to lose you Monday because I'm on a field trip with juniors. I'm losing you tomorrow.
Oh my gosh, so we don't have to for like 5 days.
Monday's junior trip. We need one more.
No, it's 2.
No, it's not. Those are the same thing.
Oh.
Can anybody do one with another negative radius? Let's keep it -2. -2, 9 power 4. 9 power 4 should do it. Because if you think about 9 power 4, you'd start here. Oh, I'm going the wrong way. I'm drawing negatively. You'd rotate, you start there, and then you go a little bit more, wouldn't you? So yeah, that's good. Anybody got another one? Maybe we make the radius positive again.
You could just keep adding and subtracting. Can you get like 2 and then power? But could your y be negative from that?
5 power 4.
Yeah.
2 -3 power 4. That would work. -3 power 4 would put you right there.
Can your x and your y both be negative in something more?
If you want, you can. We can try and make them both negative. What's wrong with that? Negative and a negative. So we know it's going to be -2, right?
Yeah, and then your it could be -4 or power 4.
If you want it to be a negative angle, power 4 doesn't work.
Would your -3 power 4 work again?
Think about the negative rotation from here to here.
Yes.
-7 power. You might need to work with degrees or convert. So that would be -315 degrees. -7 power. Of course, the goal was to get 2 points, but we come up with 4. That's fine. Hopefully you get it. That does confuse some kids when you ask for more than one equivalent point. It's not too bad. Just gotta think about rotation circle. And
Okay.
yeah, you did say something, Corey. You said all you do is add and subtract what? 360.
Yeah.
So that's what's happening, isn't it?
Yeah.
You're adding and subtracting 360.
How did you, when your 2 is positive, how did that work?
When the 2 was positive,
Like in the 2 and then the -3 pi over 4.
when the 2 was positive, I wanted same direction. I wanted to go towards the angle, not away from it.
225?
So I want anything else that would get me at 225 degrees, whether it be positive or negative.
But if your x was
Negative,
positive, you'd be more to the right. Right?
I think you mean negative in this case.
No. When you had a +2,
If I make the radius positive, I need the angle to be down here, because I want to face the angle.
yeah, draw all that out as you say it. You can tell me all day long about that.
So if I want the x to be positive, that means that I run towards an angle, right? So I need to be aiming at something that gets me to 225 degrees. That's if the x is positive. I want to go towards that angle.
But why don't you move to the right at all if it's positive? That's what doesn't make sense.
You're not.
I know why we went.
See, the arrow I drew isn't there.
I know that. But when
Now, if you were talking about something at maybe 120 degrees and the x was positive, yeah, you'd be running towards it.
oh, wait a second.
You confused yourself again. Because you had it.
I know I had it, and so I just had to. I just can't have anything. I've got to make it more complicated until I don't get it where it's all that functional.
If there's not another one, we can do another one. Oh yeah, there's these. Why don't you guys just try to plot these? I don't know, spend 2-3 minutes plotting. That's a big thing, you can't plot them. Next, I think after this is a polar eclipse there. Converting. I don't think it's converting yet.
Yeah.
No, they give you little formulas. There's converting. You okay?
I'm getting grandkids.
You guys agree with me?
Um,
No? Which one?
two of them.
That 3 ain't bad. Let's see. It's passing now.
Why did your C? Why did you go left?
You've got to run towards 135 degrees, not away from it. The radius is positive.
Oh, my circle.
So you've got to run towards it.
I thought you were just trying to like line up in the general direction. You've got to like, because if you're going to pi over 3, then why are you going this way?
The angle was 60 degrees, but the distance from the origin was -2.
Yeah, so you can go up.
No, that'd be positive. Or that'd be, If I had 2 pi over 3, I would have gone up. I'd run towards the end.
Oh, okay, no, I didn't know that, Okay, everything else makes sense.
Again, this is more or less like you tell somebody a bearing. That's what this is. You know, the target's north by 20 degrees, 3 clicks. That's what this is. Okay? But the reality is, like, of course, now with computers, the computer's going to convert that to the XY coordinate plane. That's where the real skill is, converting between the two.
Okay, we may need to do like a few more of those.
We can do more of them Tuesday, okay? I know you're going to forget by Tuesday, so just remind me first thing Tuesday, and we'll do a couple of those.
I was talking with some recent kids, and apparently they're doing now with sine and cosine.
For what?
No, mission did, and they're like, we haven't done that yet. Yes. And because I mentioned, they're like, we haven't fully covered that yet.
This is all you guys are missing, other than the algebra 2 stuff you forgot.
Yeah, it was annoying that I forgot.
Because
I knew I could do it.
Tatum's exact words. But the guy who won that thing got 36.
Yeah.
Who
We're in
No
the
doubt.
second.
No doubt.
Where's he from?
He's from Greenfield. His dad teaches physics and astronomy.
What's his name?
His dad's name is Cruz. I guess the kids.
Is he our age?
A lot of them.
Anyways, you might write this down. You actually know these formulas. None of those are new. None of those formulas are new. You got the circular approach to trigonometry. Cosine is x over r, sine is y over r, tangent is y over x. X equals r cosine. I don't even remember where we're doing it, but I know we've done it. It's too tired to think about what it was. I think it was back on the circular approach, to be honest with you. It's all old stuff. And then there's Pythagorean theorem. Nothing new to it.
So we got that little graph again.
The graph is to kind of give you an idea of where it came from. Because like cosine, if you look at the triangle, adjacent over hypotenuse, right?
Yeah, I should use myself.
You look at the triangle, tangents y over x. That's what the graph is for. Nick Gleason is as far behind as I am in teaching my 5-year-old his letters. He's a street person. My wife is all, no, I actually believe in learning at a natural level. I don't agree with the way we teach. Ready or not, here's freak out. Ready or not, here's algebra 2. I don't agree with that. So I haven't taught the kid anything unless he had interest. Who haven't? I was going to teach him how to read at 3. Now that he's actually showing interest in learning how to read, guess what we're doing? Anyways. Find the Cartesian coordinates. What's that mean, Cartesian?
Squares.
Squares, your x's and your y's. That's what that means. Cartesian is the x's and y's, x, y, x's. I don't know if that word gets used a lot in school. Most people just call it the x, y axis, don't they? Anyways, find your x's and y's with polar coordinates, 5, 2 pi over 3. So what'd you just write down for x? R cosine theta. And I did try and teach you this back when we were doing the circular approach. What's the radius? 5 times the cosine of 2 pi over 3. You're at 2 pi over 3, negative 1. Positive 3.
What do you do with five?
Well, multiply it. You evaluate the cosine of 2 pi over 3. And I do remember when we were trying to do this with circles, you didn't like this part. Oh, I'm having like dyslexia with kids. It's bad. I've been writing down the wrong thing on everything, but I didn't do any drugs. Maybe I should have. Maybe I should have gotten some help from somebody.
What would I not like about this? Or did I
For
not
some
like
reason, that blew your mind, that step right there. I don't know why. It did. Anyways, what's 5 times negative half?
Negative 5 times.
Negative 5 halves. So there's x, and how do you get y?
5 times root 2.
R sine theta, I'm gonna write that down. So still 5 times the sine of 2 pi over 3. That one is the root 2 over 2, right? 5 times root 3 over 2. Which I reckon is 5 root 3 over 2. I don't know. Years and years of pushing buttons and jumping there. One of my kids in my last class got mad that I kept getting on to them about memorization. Because she can't memorize. She was like, as a particular person. I don't know how to teach math without memorization. It's just got to be memorized. That's so bad? It's actually really easy. It is when you're just talking about points.
Don't tell me what's easy when I'm over here getting excited that I understand it.
All right. Other way around. What do we have here? We have points, don't we? What's it say about tangent of theta?
It's x squared plus y squared equals r squared.
No, tangent of theta. That's a big deal. Because see, if you're going to polar, you need a radius and an angle. Don't you? So you have this little line that says the tangent of something is y over x. Guess what that gives you? That gives you an angle. And you also have x squared plus y squared equals r squared. What does that give? That gives r. Now, you probably do need to realize something because the calculator may or may not do this for you properly. If you plot -3, -4, aren't you going to be here? Your angle is going to be over 180 degrees. Right? Calculator's not going to do that. Well, actually, you're not allowed to use calculators. I'm stuck in algebra 2 on Friday. Sorry, I'm thinking algebra 2. Algebra 2, we use calculator. We're not in algebra 2. Maybe we should be for this. I don't think you guys know this pattern. Tangent is opposite over adjacent. Not that you need it, but the missing leg is 5, right? 3, 4, 5. That's your radius. That would just drive right there. Anybody ever memorized the angle opposite of a 3 and 3, 4, 5? I never have. It's like 27 something, 28 something. It might be bigger than that. It might be 30 something. I don't know. So it turns out you will actually need calculators for this. You will. I kind of thought you would on boulders. On your challenge exam, they really won't have you do anything other than just do straight up conversion. They're only going to pick things you can work with. But if the tangent of theta is y over x, 4 over 3, how do you find theta?
Tangent 4 over 3.
Theta is the arc tangent, 4 over 3. And I don't know what you remember about this, but this is going to return an angle in quadrant 1. What did it spit back?
53.13 degrees.
53.13 degrees. And again, what's the problem with that? It's in quadrant 1. Where are we?
Quadrant 2.
The nice thing is vertical angles.
Out of 20.
There's a 53.1 degree angle in quadrant 1, there's a 53.1 degree angle in quadrant 4 of the weapons. David's right, he said add 180. And you'll have it. You just got to think about where you're supposed to be. So 233.13, right? So we have our radius of 5. We have this ugly thing, which we're not going to do. Nobody does polar with degrees. What should it be converted to? Radius. At least no mathematician does polar with degrees. And it's going to be fugly. 223.13. What do you multiply by? However 180 is right. There's the radian, about 3.89 or something. Now, what we could have done, instead of messing with degrees, although it's harder, is you could have put your calculator in radian mode.
Oh, that's right.
You've done arctangent of 4/3. You got that little decimal there, 0.927. Which is kind of hard to understand, but to go from here to here, don't you rotate 180 degrees? Huh?
I got 4.06, or 9.
If I type in 223 instead of 233? Good. I was about to catch that too, because I was working with radians now. 4.06 up there. All right. What I was saying is, had you put your calculator in radian mode, it would return an angle in radians. And instead of adding 180 degrees, you could have added pi rad. Still accurate out to what, the 6th decimal? So it doesn't really matter what you do. So there you go. About 4.07. That's probably a little bit harder to do than the other way around. You have to find the angle. Let's make up one of these that might be on your challenge exam. There we go. Challenge exam would do something using nice points that you're comfortable with. That's what you do. They do something like -1/2 and, I don't know, positive √3/2. That's what it would do. It would say convert these into polar coordinates. That shouldn't be too hard for you. But if you don't know it, you know, like if you don't know what the radius is, because some people don't, the radius can be found by doing square root of 1/2 squared plus √3/2 squared. Now what I did there is I jumped to the Pythagorean theorem, didn't I? That's all I did. I just jumped to it. And by God, if you do that, you're going to get 1/4 plus 3/4, which is 1. That should have been known. Where did those points come from? What circle?
Yes,
The unit circle. On the unit circle, what is the radius? 1. So the radius is 1. And on the unit circle, what ordered pair has those coordinates? Sorry, what angle has those coordinates? 2/3. Let's see, 2/3 is 120. Yeah. 2/3. That's what your challenge exam would do to you. So your polar is just 1, 2/3. Now they might try and do something else. They might think about maybe a negative angle. What would get you to 2/3 with a negative angle? Keep the radius positive, negative angle. -4/3. -4/3. What if you made the radius negative? Made the radius negative, you would want to be down in quadrant 3 when you draw an angle, wouldn't you? What's that? 5/3 seems right to me. I'm thinking in my head right, it seems right.
Maybe it's-
But it is negative 5. So keep in mind things like that. They might try to make it a little more difficult by making certain aspects of the multiple choice exam negative. Seems like something I would do. It's called a challenge exam, isn't it? Not supposed to be entirely easy. But you only have to get a 70 on it. I copied and pasted this instead of trying to come up with all this stuff. This is the gist of the next couple of things we're going to do entirely in the calculator. But sketching a graph of polar equations. This is r equals theta, which means that the radius is equal to an angle. That's what it means. You have a radius equal to an angle. That actually happens at some kind of nice points you're aware of. That is true for a couple of nice things, 0, 0, 5, 4, and so forth. And the reason those points were picked is because they're easy to plot. But the nice thing about polar equations is all the graphs are spiral, which are circular in nature. I think the next thing in your notes is you're supposed to try to figure out the equation for something where the radius is 3. Huh? But isn't it something for r equals 3?
Yeah.
Yeah.
Get the graph of the polar equation, r equals 3.
What do you think it is? Somebody tells you r equals 3, what do you think it is? Circle. Circle. Somebody tells you radius is 3. It's a circle. That's what it is. It goes 1, 2, 3, 1, 2, 3. Mine will look like Stewie Griffin's head. You know who Stewie Griffin is. Unless you want to do that. Since you guys have your TI-84s out in front of you, please change the mode back. Please do not leave it in polar mode. In mode, what is that, 5th row? You see function, parametric, polar, and sequential. Those are all different types of graphing. Function is x, y axis. Parametric is where you have 2 simultaneous equations, one for x, one for y, which is how most graphing in the real world, when you talk about real world stuff, is done. It's parametric equations, which you know nothing about. You won't until later. Polar.
The calculator also looks like 2.
Yeah. Then do a zoom box or zoom square. It won't. Anyways, if you change it to polar and press enter, and then go to y equals, now you have equations written in terms of r, don't you? They're r equals, as in radius is. This was r equals 3. If you do a zoom 6, it will look like Stewie Griffin's head. If you want it to look like it should, you don't do zoom 6. Choose zoom square. You know why you choose zoom square over zoom 6? Because the calculator goes out 10 units and it goes up 10 units, but it's a rectangle, isn't it? That means that each thing on the x-axis is a little bit wider than it should really be in reality. But zoom square is an attempt to correct that. And there's your circle.
That's kind of halfway, mine would just put a dot.
Oh, I
Mine's just a dot.
Yours just a dot.
I don't,
Are you in radian or degree mode?
I'm in degree, that's probably the
I probably should have specified that.
Is
Yeah.
this just a smaller graph?
I don't know.
You know what?
I got 2 points.
I know, I just made that. I was saying you didn't come together.
Talking to somebody who doesn't fear death.
Huh?
I don't care.
No, I'm not scared.
The only aspect of death I fear is when it happens.
Do you have life insurance?
Probably should.
Jeez. No?
I still think I'm gonna live forever. Believe me. I know better than that too.
Look at the effects on that weather out though. It's like 6 foot in the air.
If I was y'all's age and there was a tornado 2.5 miles away, I would get my truck and I'd go find the tornado. I did that several times as a teenager. I got really close to one. It went about, I don't know, 2,000 to 3,000 feet in front of me down Parasite.
Well, we don't want to die.
There's a semi truck was in front of me. He didn't stop either. It was just
here.
Well, he didn't know. He was driving, he'd probably been driving for 10 hours. He didn't know. All right, sketch a graph of polar equation R equals 4 cosine theta. Back in 2019, the last year I taught this stuff before Rona, we used to do this by hand entirely, but I'm not going to do that with y'all. You got a calculator in front of you. Polar graphs are kind of cool the way they look. This is saying the radius is 4 times the cosine of an angle. And if memory serves me right, this will be a circle whose diameter is the positive x-axis. Do a zoom square if you want to see the real thing. Zoom 5.
Just do 4 cosine what?
Theta.
Press where you.
It's the x key. Notice x is actually xt for parametric.
Oh,
Theta, and then what's the other one? N for
well,
standard.
then it's different.
Calculator does a whole lot of stuff. You maybe learn 5 to 10%. Plus you can program those. Those are Python calculators. Anyways, there you go. It's a circle. The next one's kind of cool. This is called a limacon. With an inner loop. That's what she's called. She's a limacon with an inner loop.
Oh,
Yeah, they make pretty things, don't they? That's 4 sine of theta plus 2. And again, go zoom 5 for the square.
How is it?
There's a cardioid, which is not in your notes. It's been a long time since I've done a cardioid. There's one that looks like a heart, too. That does kind of somewhat resemble a heart, doesn't it? But there's one that doesn't have the inner loop, and that's called a cardioid. And I'm trying to think of how it was done. I actually think if I change that to cosine, it might become a cardioid. But it might just be a horizontal. No, it's just a horizontal line. I don't remember the cardioid. I don't remember their setup. That's a line called inner loop. And the next one would be a rose petal. That's what they call it. They call it a rose. Funny things happen when you start changing the inside, because that speeds up the period of graph. This will look like a rose petal, or a rose. That had a 3 theta inside of it. How many petals did it have? 3. Kind of interesting. Look what happens if that was with an odd number. Look what happens if you put an even number in there like a 2. You'd think, based on what you just saw, it'd have 2 petals. That's
these
4.
need to be in radians.
Radian.
Right now?
Yeah. We're in
All the
radian.
time.
You're graphing a trig function, you're a radian.
I tried to make a heart, it looks weird.
I don't remember the setup on the core yet. I haven't done them since 19.
I've been in
I think
radians.
-5 sine theta plus 7, that looks weird.
That might be it. There's an odd number in front. That might be it on the cardioid. Now that was with a 2. Guess how many petals you have if you make it like a 4?
You're right, it is an odd number, I'll change 7 those letters.
Yeah. So when there's an even number in there, you actually double the number of petals. When there's an odd, you keep the number of petals. Just kind of interesting about the rose petals. And that's it for today. When you get back, I guess next time I see you guys will be Tuesday. And I guess we'll do the fun stuff in this lesson.